All right, today we are going to talk about another new topic. So get your notes title down, 1.5 notes in behavior of polynomials. 1.5 notes in behavior of polynomials, and you do not need to write down this first sentence, but please just listen and make sure you're following along. So here we go. In behavior of a function tells us the direction a function goes on the graph as x approaches positive infinity, and that's far to the right on the graph, or as x approaches negative infinity, and that's far to the left. You can determine, okay, so this I want you to write down. Key idea. You can determine the end behavior of a polynomial function by looking at the degree and leading coefficient. Leading coefficient. All right, and we will write down pretty soon here what those represent or what those mean. And then please also write down this. End behavior is written in the following way. And I want you to actually write down, this is how we're going to represent end behavior. So write this down as x, and then this little arrow means as x approaches, or we could think of it as goes to. All right, and then as x goes to, our options here are plus or minus infinity. We have to choose, and we're going to learn how to choose which one our answer will be. F of x, so as x goes to plus or minus infinity, f of x goes to plus or minus infinity. And again, we're going to have to choose positive, is it positive infinity or negative infinity? Okay. So hopefully you got that down in your notes. Two things we need to know before we can determine end behavior. So there's two important things for us to know. First, the degree of a function. So write this down. The degree of a function is the highest exponent on x. The highest exponent on x. The highest exponent of the function. And then the leading coefficient of a function is the number in front of the x, the number in front of the x that has the highest exponent. That has the highest exponent. So when we're looking for degree and leading coefficient, it's always going to be easiest to find the degree first, and then you can look at the number that's in front of the x that has the highest exponent. That's going to be your leading coefficient. Okay, so let's do an example. Please write down this example so that you know how to find the degree and the leading coefficient. What is, if you want, you can just write down this function, and then we're going to write down the degree and the leading coefficient for that function. So what is the degree and leading coefficient of f of x if f of x equals negative 4x cubed plus 7x squared minus 5x plus 11? All right, first thing we're going to find is degree. And then the second thing we're going to find is leading coefficient. And just so y'all know, I will be representing leading coefficient by writing LC from now on. And degree, I will probably just abbreviate it DEG. Okay, so degree. Let's look over to our function f of x. The degree is the highest exponent. So we're going to look at all of the exponents in the air. We have 3, 2, that's a 1, even though it's not there. What's the highest exponent? 3. Right here. This is our degree. So degree is 3. There we go. Leading coefficient, we're going to look at the number that's in front of the x that has the highest exponent. So go to the x with the highest exponent, which is here, and look at the number in front. That's my leading coefficient. Leading coefficient, negative 4. Boom. Okay, now that we know how to find degree and leading coefficient, we're going to fill out a chart that tells us what do the ends of a function do. What do the ends of a function do based on the degree and the leading coefficient. So please draw this box. It needs to be a big box. It should take up like half of your page. Determining the end behavior of a polynomial, just the ends, not the middle. What are the ends of a function doing? Draw this box. It needs to take up your entire page. All right, here we go. So we're going to write on top of the box, we're going to write degree. So up here, above it, kind of, this top side is going to represent the degree, and then the left side is going to represent the leading coefficient. Okay, and then when we're talking about the degree, there's two things we care about. We care about, is the degree even or is the degree odd? So we're going to label the top even or odd. When we're talking about the leading coefficient, we care, is it positive? So I'm going to put a plus sign on the left side, or is it negative? Minus. Positive or negative. Okay, and I'm going to draw the ends of what a polynomial looks like, just the ends. So in the middle, I'm going to put like a dot, dot, dot. That means we don't know what happens in the middle of the function. So if you have an even degree and a positive, actually, let's just talk about, hold on, let's write a note. Leading coefficient tells me about the right side. So, yeah, let's talk about how the leading coefficient tells me about the right side. So make that note. LC tells me about the right side. So if the leading coefficient, let's put the dot, 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 dot. That's like the middle of the graph. We don't know what's happening there. We're not going to worry about that. But if the leading coefficient is positive, then the right side is going to go up. So leading coefficient positive, we get right side up. If the leading coefficient's negative, the right side of the graph goes down. All right, so let's go ahead and represent that on all of these. So leading coefficient is positive right here on this top row. So the right side of the graph is going to point up. On this bottom row, the leading coefficient is negative, so the right side is going to point down. Leading coefficient negative, right side points down. Okay, now let's talk about degree. The degree tells us if the left side goes the same, so degree says left side same or opposite. Or opposite. Same or the opposite of the right. Okay, so if the degree is even, that means same direction. So that means that in this situation, where the right side goes up, if the degree is even, your left side's also going to go up. And then in this situation down here, our right side is going down. So because the degree is even, we have to go the same direction, right or left side down. All right, odd means opposite. If the degree is odd, we're going to go the opposite direction. So the right side's up on this graph, but the degree is odd, so we're going to go down on the left. And then the right side is down on this graph because we have a negative leading coefficient, but the degree is odd. That means we're going to go opposite, which is up on the left. All right, this is how I remember this. Odd starts with an O, opposite starts with an O. So if the degree is odd, that means opposite direction. And then I just remember positive, leading coefficient being positive means up, because like it makes sense that positive goes up and negative goes down. But you need to remember that the right side is with the leading coefficient, and the left side, you need to look at the degree. Okay, so now let's actually write our statements about the directions that the graph is going. All right, so the first statement we're going to talk about as, because you need to be able to write these, as x goes to positive infinity, where is f of x going? F of x goes to, okay, x being positive infinity, Actually, let me do this in a different color so we don't mix up, so we don't mix up our degree and leading coefficient. So I'll do it in this one. As x goes to infinity, positive infinity, f of x goes to, we're always going to write two statements. So let's go ahead and get the start of these statements. As x goes to negative infinity, f of x goes to. All right, the first one, positive infinity, x going to positive infinity. That means look at the right side of your graph. Right side, x is going to positive infinity. And then left side of your graph, x is going to negative infinity, because negative infinity is very far to the left, right? And then positive infinity is very far to the right on your x-axis. So this is how we start every statement. Now how do we finish? We have to look at what direction is f of x. F of x, remember, f of x is the same as y. F of x equals y. So what direction is it pointing in the y direction? Is it pointing up or down? And remember, this is x, this is y. So we're talking about x being positive infinity. And look at this first graph. As x goes to positive infinity, that's on the right side. Which way are we going? We're pointing up. So f of x goes to positive infinity. All right, because positive infinity is up on the y-axis. Negative infinity is down on the y-axis. Negative infinity is left, positive infinity is right. Okay, cool. So now let's finish the other statement. As x goes to negative infinity, so looking at the left side of this graph, where are we pointing? Where is our y pointing? Up or down? It's going up. And what is up? Positive or negative infinity? Positive infinity. So that's how we're going to write these statements for all of these graphs. So let's go ahead and get that down. As we start every statement, as x goes to positive infinity, f of x goes to, that means look at the right side. And then we do as x goes to negative infinity, that means look at the left, f of x is going, and that's saying up or down. Okay, so as we look on the right-hand side for this graph, as we look on the right, our arrow is pointing up, so that means positive infinity for the right side of our graph. As we look on the left, of the side of our graph, our green arrow is pointing down. So that means as x goes to negative infinity, f of x also goes to negative infinity, because negative infinity is down. All right, let's do this one. As x goes to positive infinity, f of x goes to, do you see how I start this statement off the same every time? Okay, positive infinity for x, that's on the right-hand side. Right-hand side, is it going up or down? The arrow is pointing down, so f of x, or y, is going to negative infinity on the right-hand side of the graph. As we look on the left, so this is x goes to positive infinity. As we look at x going to negative infinity, that's the left side of your graph, left, our arrow is also pointing down. So that means f of x, or y, is going to negative infinity. Okay, cool. Last one, we'll start the same way. As x goes to positive infinity, that's the right-hand side, f of x goes to, and then we're going to write another one. As x goes to negative infinity, that's the left-hand side, f of x goes to. All right, let's do the first one, the top one, the right-hand side. On the right-hand side of the graph, as x goes to positive infinity, f of x is going down, negative infinity. And on the left-hand side of the graph, as x goes to negative infinity, f of x, or the y, the arrow that is representing y, is pointing up to positive infinity. Okay, so how the heck are we going to use this? Well, you're going to have to be able to write these statements, that as x goes to, f of x goes to, those statements, by looking at the function. So let's go ahead and see some examples. All right. And you will do the practice. So I'm going to do the example, you'll do the practice. Example 1. What is the end behavior of the function? So when it asks for end behavior, it's asking for those as x goes to statements. So I'm going to write as x goes to positive infinity, f of x goes to, and I'm going to write the next one, the as x goes to negative infinity. As x goes to negative infinity, f of x goes to. Okay. Where is x positive infinity, on the right or the left? x is positive infinity over on this side. So where is our arrow pointing? There should be an arrow on this graph. Our arrow is pointing down to negative infinity, right? X is going to positive infinity, but y is going down. So as x goes to positive infinity, f of x goes to negative infinity because our arrow is pointing down. Cool, let's go to the left side of the graph. Let's do this one. As x goes to negative infinity, f of x goes to, we have to pick positive or negative infinity. So let's look at x is negative infinity on the far left side of the graph. Where is my f of x or my y pointing? It's pointing up to positive infinity. So that's what we're going to put in this statement, positive infinity. Done. Okay, I want you to write two statements for this practice. There should be arrows on the ends. I want you to write both statements. You should have two statements. I will start them for you. As x goes to positive infinity, f of x goes to, and you can like spell them out. As x goes to negative infinity, f of x goes to. All right, answer these ones. Go ahead in your OneNote. I need to see what happens as x goes to positive and negative infinity. Go. Okay, as x goes to positive infinity, f of x goes to, okay, x is positive infinity on this side of the graph, so we need to look at the arrow on the right-hand side of the graph. It is pointing down, so y is going to negative infinity. That means we're going to put negative infinity here because f of x is the same as y. All right, now we need to look at the right-hand side of the graph. So as x goes to negative infinity, or sorry, the left-hand side of the graph. Ooh, that was a bad mistake. Sorry about that. As x goes to, x is going to negative infinity. Where does f of x go to? It's pointing down. So y is also going to negative infinity. Both are going down. Okay, we have one more example. One more example. We are going to identify the leading coefficient, degree, and end behavior of p of x. This should be very fast. Okay, so I'm going to start with the degree, always the degree, even though it said leading coefficient first. The degree is the highest exponent. So sweet, the degree is 3. The leading coefficient is the number that's in front of that x with the highest exponent, -4. And now we're going to use our chart. So if the leading coefficient is negative, that means right side down. And then the degree is odd. Odd numbers cannot be divided by 2. The degree is odd, so that means left side, opposite direction. So now I'm going to sketch my end behavior very quick, put my 3 dots. We don't know what's happening in the middle. You know, on these polynomials, we could see all these curves and bounces in the middle on our example, but right now we're just focused on the ends. That's all we're caring about. So that's why we're putting 3 dots, like basically the middle we're just representing with 3 dots. Okay, we don't care about the middles right now. And now we're going to draw our ends. First with the right side down, and then with the left side, which has to go opposite because of the odd degree. And let's write our end behavior now. As x goes to infinity, f of x goes to negative infinity because it's pointing down on the right-hand side. As x goes to negative infinity, f of x goes to, it's pointing up. The arrows are pointing up, so it's positive infinity. Sweet. I want you to do the practice. Go. All right. Identify the leading coefficient, degree, and end behavior. We're going to do the exact same thing. First, find the degree. Degree is the highest exponent. Ooh, this one is extra tricky. The highest exponent is 6. Hopefully you didn't get tricked by that. Then we're going to do the leading coefficient, which is the number that's in front of the x with the highest exponent. Well, that's 1. Positive 1, right? Okay, sweet. Because the leading coefficient is positive, that means right side up. And because the degree is even, that means left side same. So Now we're going to draw our little center of the graph. We don't know what's going on there, but we do know that the right side is going up because the leading coefficient is positive. And we know that the left side has to go in the same direction because the degree is even. And now we'll write our statement to finish it off as x goes to positive infinity. That's the right side of the graph. F of x is going up on the right, so positive infinity. And then as x goes to negative infinity, f of x is also going up on the left-hand side of the graph. So positive infinity. Sweet. That's notes for today, y'all. Good job.